let's do number 8, which is interfaces. And here we're allowed to assume that we have a correct implementation of ArrayDeck and linked list deck throughout this problem, and that it implements this deck interface that's given over here. And part A is asking us to consider this deck interface and add a default method, reverse, that will reverse the deck. So remember, a default method in the interface is just sort of like, it can be overridden, but it's like the default implementation that fits with the interface. So our interface has the methods add first, is empty, print deck, remove first, add last, size, get, and remove last. So the tricky thing about this problem is that you can only use methods to reverse your linked list. Because we can't use any instance variables, we're just limited to these methods to modifying our deck. So this problem could be solved in a lot of ways. So here are some ways that we could solve reverse. Any of these are valid, which would be like converting reverse to an array and then reversing from there. This would be awfully inefficient. But we could also just reverse recursively. So I'm going to go over how to do reversing recursively because it's a lot more of an elegant solution, and it's quite important to learn how to reverse recursively. It's just a good thing to know because it's quite involved. So first, let me just draw out a sample array deck that I will reverse. And in this case, I'm not really going to draw the pointers because we kind of abstracted them away here with the deck interface, because we don't even know how like the decks are going to be implemented. We just know that they'll have these kinds of methods. So let's just say I have 1 pointing to 2, pointing to 3, pointing to 4. Okay, so if I want to reverse this deck, I have to mutate it. Remember that this returns nothing, so we're mutating the list to reverse it. So we have 4, 3, 2, 1. So if I want to, so this is what we input, and then this is the result. Now, if we want to reverse recursively, whenever I have recursion to do, I break it down into 3 steps. The first step is the base case. The second step is reducing to the base case. And the third step is to do the extra work. So there's some extra work involved. For example, here we're going to have to somehow reverse it after we reduce to the base case. So let's ask ourselves, what is the base case for reversing? And the base case for reversing is a very trivial one. It's that if you have a list, here, if we have a list of size 1 or 0, so basically if the size is less than or equal to 1, then you just do nothing. Why? Because a list that is of size 1, when reversed, is the exact same list. And because we're mutating, so here we have to be mutating, we just do nothing. So then how do we reduce to the base case? Well, reducing to the base case, in this case, we don't have any sort of like next pointer. We don't know how to get the next item. But what's another way that we can get the next item? Let's think about it. So I have these methods here, and if I want to, usually when you're doing like a linked list sort of reverse, you would call like reverse on like list.next. But because we don't have that available to us in this interface, what's going to happen is that we need to somehow move from this one to this one. And let's just check out the methods that can let us do that. So add first is not going to help us because that won't move us to the next element. We won't be able to get to 2. Is empty only tells us if the list is empty or not. Print deck won't help us either. Remove first will remove the 1, which will make our list go to 2, but we're going to have to do something about removing the 1 because we don't just want to lose all of our elements. Add last is just like add first. We can't use it to move on. Size, we can't do that. Get, we can do that, but that kind of breaks the recursion if we're going to do it recursively. And then remove last is going to let us move the other way, but we want to move left to right. We don't want to move from right to left. So when I say we can do remove first, because remember we're just mutating the list. When we remove first, we mutate the list such that the first element is gone. And now we are effectively left with the rest of the list when we call reverse again. So the thing is that, reducing to the base case means that we're going to remove first, but then we don't want to actually remove first. We need to save. We need to save the item that is removed. So now let's think about it at a case where it's just 2 items. 2, 1. So if I call remove first and I save this, so let's say like a temp will be pointing there, or the temp will be 2 because I removed first, and you get the item back after you remove first. So temp would equal remove first, and then your list will look like this, but temp is actually equal to 2. So then when we call reverse on 1, it'll just return itself. It actually won't do anything, it'll just return. So then after you call reverse, because you just removed it, you just get back 1. So then how do we add back the element that we just moved to actually reverse the list? Because when you call reverse, you'll have this, but what you actually want is this. And to get that, we just have to tack on our element to the end of our reverse list. So the base case tells us that a list of size less than or equal to 1 will just return itself. And what that actually is telling you is that when we reduce to the base case, we can kind of trust ourselves that calling reverse on after removing the first element will give us the correct reverse list after. So reducing to the base case is removing first, but our extra work involved is to add last to the reversed list. So let's write that out in code. So first we want to say if size is less than or equal to 1, we are going to return. But else, what we will do is we will let temp equal remove first, and we will reverse because we have mutated our list such that it is now missing 1 element in the front. And then what this is like, this is sort of like your recursive leap of faith, where you just believe that calling reverse will give you back the rest of the list reversed without temp. So calling reverse on this will give you the rest of the list reversed. And that means just to reverse the list, the whole list, we just have to add last our temp. So what this is doing is when you are doing the recursive leap of faith, you're calling reverse on n-1 elements. And then your leap is that this will reverse n-1 elements. However, to reverse n elements, you just reverse n-1 elements, and then you add last the first element, which is temp. So now let's write it out. If size is less than or equal less than or equal to 1, we'll just return. And then now we can just put item temp equals remove first. Okay. And then we will reverse. And then we will add last temp. So just to map between here and here, this call to these two calls are basically reversing n-1 elements, and then this call lets you reverse up to n elements, and that's part A. Let's do part B, which is giving us this default method to the deck interface, and then we also given these methods from ArrayDeck. So these are methods that exist solely in the ArrayDeck class, and not the deck class, or the deck interface. So they're telling us to look at this problem below, which is just making a bunch of calls, and we just have to pretty much figure out, will it be a compile error, will it be a runtime error, or which call is it going to actually make? So let's first start out with these kinds of problems. This is testing you on dynamic method selection and pretty much method lookup, so multiple dispatch. And when we're looking at this, it's good to have a table like Hug had in lecture, where you have a variable name, you have its static type, and you have its dynamic type. So here they initialize deck integer d to be a new array deck. So it's got a static type of deck and a dynamic type or an instance type of array deck. So then when we do d.addLast10 and d.addLast20, we have 10, 20. So D is pointing to this list with 10 and 20. We then make a new array deck, which has static type array deck, because we declare it to be such. And it's going to have a dynamic type array deck, because it's also an instance of the ArrayDeck class. And then this is going to have 30 and 40. So I'm just keeping these numbers here in case we run into a runtime error. So now we've finished half of this program, so the initialization part. And now we get to the real meat of the question. So first it's asking for d.prepend and d.prepend AD. So here, for variable or for method lookup, you have to remember that it's static unless you have an overridden method. And here we see that because D is of type static, static type deck, that means that when we're looking up methods and our deck doesn't have like a prepend method that gets overridden, even though it's of dynamic type array deck, we're going to get a compilation error because our deck interface doesn't specify a prepend method. And because D is of static type deck, you get a compilation error because it's like, hey, you're a deck and I can't find your prepend method. So those are the first two. So when you try to prepend, it's not going to work, simply because D is of static type deck, and because prepend is not a method that gets overridden, you're still looking in the deck class for the method to use. Now here, when we call ad.prepend, D and AD, we won't get an error because AD has static type array deck, and if we look into the ArrayDeck class, we see that there's a prepend method. So instead of AD and these two calls to prepend getting a compilation error, we're just going to call method D. Or actually, scratch that. For ad.prepend D, the thing to remember about, so here, let's have a method selection rules. So it's all going to be based on static type unless we override. And then also the parameters are based on static type. So here, because static type is ArrayDeck, we're just going to be looking at these two methods. The first one, ad.prepend D, is making a call where the static type of D is deck. So that means we're going to use this method because this one takes in a deck. Now when we do ad.prepend AD, the static type of this is ArrayDeck. So we're going to use this method because we have these two methods, prepend, this is overloading, and overloading is dependent on our static type. So the parameters are dependent on the static types. So we have D and E for the third and fourth line. So then let's move on to these append calls. So AD.AppendD is telling us to append a deck. Now, the interesting part about append is that we have an overridden method append that overrides append from the deck interface. But then we also have this overloaded append method, which will instead append an array deck instead of just like a generic deck. So when we do AD.AppendD, again, let's look at our method selection rules. Now, because we have some dynamic method selection going on, so here override is, well, so you select based on dynamic type when you override. Now, what constitutes us overriding something? Well, here, when we do AD.AppendD, AD is of static type ArrayDeck, and then D is of static type deck. So what that means is that we are in the ArrayDeck class, and we're looking for an append that appends a deck. So in this case, C is going to get called. Why? Because static type is ArrayDeck, so you're just going to look into the ArrayDeck class. We're not actually like invoking this dynamic type selection because we already have our static type as ArrayDeck, and now we're just trying to match the static parameter. So even though D is of dynamic type ArrayDeck, because we're only looking at the static type when we're referring to parameters, we're going to use this one, which has the type deck, which is the static type of D. So then it gets a little trickier when we do AD.AppendAD. Now remember, AD is static type ArrayDeck, so we're still looking in this class, but now we care about the static type, right? And AD has a static type of ArrayDeck. So when we're looking through the ArrayDeck class, we're going to pick the method that most specifically matches the parameters given. And in this case, the specific match is B, because we are appending an ArrayDeck, static type ArrayDeck. And this one is just more generic. So in the case of the second or the sixth line, we're going to be calling B, simply because if we just look at our method selection rules, we're going to use the static type unless we're overriding a method. And in this case, we're not even overriding anything because AD is of static type ArrayDeck. And then the parameters are going to be based on the static types. Okay, so now let's do the sixth or the seventh and eighth line. When we are doing D.AppendD, remember now we are now of type D, and what that means is that there's going to be some overriding going on. And remember that our only overridden method is here. So D is of static type deck, but it's also of dynamic type ArrayDeck. So when we're doing D.AppendD, the method we have that overrides is over here, which is public void append to deck item D. And because this is overriding, we are using the dynamic type. So we're going to use the dynamic type of D, which is ArrayDeck. So we're going to be calling C. Now, when we look at the last line, where it's exactly the same, except now this is an ArrayDeck instance, so it's also static, then you might be like inclined to think that B will be called, but the reason that we're going to call C instead of B is that this D is of static type deck, which means that the only methods that we could like choose outside of our static type are ones that are overridden by ArrayDeck. So that's why like D.prepend and these two prepend calls gave us a compilation error. So if we operate under that assumption, then the only methods that we can choose when we have D as a static type of deck are the ones that are overridden. So the only one we can really choose is C. Like here, B, D, and E don't exist really to D because its static type is not ArrayDeck. Static type is deck. So that's how method selection works, and that's why the last answer is C. And that's simply because method selection, it's static type unless you're overriding. So static type is deck, and we overrid, so we only got access to C and not B, D, or E. And that's number 8.